Okay, let's open the your model actually developed for the left 8. So today actually we are going to add the chart here, especially time plot chart. So first of all, let's go to the palette, and then there is a presentation or analysis tool. And if you click this analysis tool, and then you can see the time plot over here. And let's drag and click this one and then drag and drop here. All right. Yes, let me a little bit adjust the size of this figure, and you can move this one to here. And if you click, and then basically you can see the property view here, where in other direction, add the data first. So if you go below and then under the this plot, you can have a data. Okay, and then first data set, we will add the adapter basically. So data title is adapters, and then value itself is adapters, so that we can see the number of adapters in this stock. Okay, and the color will be red. If you go below a little bit more, and you can add the potential adapters, and sequence doesn't matter, so potential adapters, and value. So this is just title, okay? And then let's type the name of this stock, which is a potential adapters, right? Potential adapters. And then we want to use a blue color for this. And let's change the appearance of this plot a little bit. So if you go below, actually you can see this appearance of this chart. And here, you select the field area under the line, so that you can see the line actually in these two lines actually in this figure. Got it? Also, let's change the frequency of the data update. So if you click this data update frequency, and there is a recurrence time, and you want to use 0.1 years, we want to update chart every 0.1 year, okay, and then display up to 100 latest data samples, latest samples. Good. Let's create another chart, and here we can actually choose the time plot. Once again, under the here, actually under the previous chart, and then let's change the name of the data set. So first title, data set title will be adoption rate, so that we can track the adoption rate over the time. And then this is adoption, you can type the adoption rate, which is this, okay? And then let's use a line color. Okay, and then go to the data update, and then we will use a 0.1. And then if you go to appearance, and then you can deselect this fill area on the line. Great. Okay, so here's one more thing. If you go to the chart here, time plot, and you can actually change the scale, especially time window of this chart. And then let's put the 8, so we can display the trend of the data for 8 hours. And same thing, let's type the 8 for the another chart as well, so that when you run the simulation model, and then you can show the chart within this 8 hours. Also, let's put another flow, actually the discard, to implement the discard behavior of the adapters. So let's add another flow, start from adapters. to the potential adapters. And if you double click this line, actually you can actually make another point here. And let's double click this line as well, so that you can make another joint here, point here, so that you can make this shape, right? And then let's click this flow and then change the name of it. So we will use discard rate for this flow. And then we will use the production lifetime and product lifetime, I'm sorry. Product lifetime. And we also, because we are going to use the product lifetime as a discard rate, so we need to what? We need to make another parameter, right? Called the product lifetime here. And then initial value is, let's say, is a 2-year, type 2. And then also change the data type as a time, and then is a 2 years, right? So you can select the years here so that you will have a 2 years. And once you have parameter, you have to make a connection from here to the discard rate, right? So that you can use it. And then here, if you click this, and then check the adapter stock, and then check the equation here, delta t function, and basically you can actually now the function subtract discard rate from the adoption rate. Okay, same thing, discard rate, adoption rate. Okay, all right, so this lifetime, I mean, this will be what? So after 2 years, the discount rate actually is 2 years, so which doesn't make sense at all, right? Let's use another function to implement the 2 years delay time in this discard rate. So click discard rate again, and then type delay, which is the delay function of the given by this AnyLogic. And delay function has a 2 argument. So first one is a rate, which is a value, and then another one is time. So product lifetime has 2 years, right? As a data type, is time, actually time, 2 years. And then first argument is a value, which will be the actually discard rate. So type the adoption rate. So which means after 2 years, same rate will be used as a discard rate. Got it? And in order to do that, actually you need to make another link from adoption rate to discard rate, right? So that you can remove the error sign here, right? Once again, delay function will spend 2 years, and then after 2 years, it will use the same adoption rate. So in other words, all adapters after 2 years, all adapters will discard the product, so that they will become potential adapters. Let's create the demand cycle, okay, of the product using the data table here. So table function, and if you go to System Dynamics palette, actually you can see that this table function. And let's add the table function here, and then type the name as demand. And then interpolation is the linear, and out of range we will use just a nearest input value. And here are the argument, and then let's start from the 1, which is the first month, and value is 3. Okay, second, third, second, and its value is 3.6. Third month is with the 4.1, 4, 6.3, 5, 7.7, 6, 9.6, and then 7, is 10.1, and 8, 9.7, 9, 7.4, 10, 8 point, 4.8, and then one more 1.8, and then yes, 11, 10, 10, 11, 12. 10 is 4.8 again, and 3.9 for the 11th, and then last one will be 6.3. So if you look at this one data set, actually it will have 12 month as an argument, and then value we have 12 values under the different argument. Use the function, okay, in AnyLogic. If you go back to the agent palette, you can see this function. Okay, let's place a function here and then change each name. So adoption fraction, and return type, if we have return type, and then double is a return value. So typically, if you know the programming, actually this one is just Java programming, okay, function using Java. So we have return value here, and then this is a program code. Actually, you can type the program code, Java code here, and then so let's type this one, demand. Yes, so basically demand is a name of what? Data table, right? So here, and then get month will return the month in the simulation. So it will start from 0. That's why we add the 1 here. So it will return the value of each month, actually from 0 to 11, right? So that's why we have to add the 1 here. And then once each argument, actually which is between 1 and 12, right? And then based on the argument demand table, we return these values. Okay, 3, 3.6, 4.1, and so on. So that adoption, actually, if this is 3, and then for the first month, and then we will divide the value by 200. Okay, so let's assume that, okay, so that we can get the adoption fraction. Okay, so we will modify the model. We are going to use a dynamic variable for as a adoption fraction. So we are going to delete this one, and then go to the system dynamics palette, and then put the dynamic variable here, and then make a connection. So it has a link, right, connected to the adoption from word of mouth effect, right? And then dynamic value, the name of this variable should be adoption fraction. And then adoption fraction that has this formula. So this name is quite similar to this one. Let's change the function name, okay? So here, this is the name of function, so adopt fraction. So let's use adopt fraction here, okay? So that this dynamic variable will call this function, and then time function will return the value of the simulation time. So basically, which will be the argument of this function, right? So, and So that's why we are going to use the time as an argument. So let's go here and then, so let's type time, and then this one is what? This should be double. So if argument is given to the this, and then the this function will return the demand using this table mentioned before. And here's one more thing. Let's add one more data. Hold the discard rate here. And the value will be what? Discard rate, right? So that you can show you the discard rate shown here, right? Through the this time float. And then let's use just default color here. Also add one more constant here, okay? To implement the expenditure of the promotion. So monthly expenditure for the advertisement. Got it? So let's go to the here, and then there is a parameter called monthly expenditures. And initial value is 1100. And let's delete the add effectiveness, replace this one with the dynamic variable. And let's delete the existing add effectiveness, and then change the name of dynamic variable here, and then make the connection right from the add effectiveness dynamic variable to the adoption from add. And then here the add effectiveness is a dynamic variable using this equation, monthly expenditures divided by 10,000, and monthly expenditure is here. And then we have to make another link, start from monthly expenditure to add effectiveness. And let's add one more variable. So go to the agent, and then here's a variable, and let's add one more variable in this model. Okay, and then name of variable will be total expenditures. And then we will update this value using an event in agent panel. Okay, this is agent, not the system dynamics. And here's the event. And event actually will generate the event over the time. And choose a cyclic. And then event will happen every month. So monthly event. So every month. And action. So in action, we need to type the equation here. So we will update total expenditure and accumulate the total, actually the total expenditure over the time every month. And then monthly expenditures, so that you can have a total expenditure at the end. In this model, so now we have a monthly expenditure and then variable having the total expenditure. And then let's add the optimization model. We want to find the optimum monthly expenditure actually to attract the potential adopters, okay? And let's create it. So if you go to the project and then under the your model, and if you click the right button, you can add the experiment here and select the optimization. And click finish so that you can have optimization module under your model. Okay, double click this main, and then now we have this optimization main, and then its property, and we can keep this main, and we want to minimize, so this is the objective, and then we want to minimize the total actually expenditure to attract more customer. So type the root. In order to access the total expenditure, you need to type the root, and the root dot total expenditures. And then we will consider the 500 cases actually to find the optimum solution. And then you can just use the existing memory actually here also. And then we need to consider the parameter, right? So currently we have in our model, we have total population, contact rate, work time, and monthly expenditure. And let's make this one as a continuous variable so that we can actually find the optimum expenditure amount for the advertisement or promotion. And then here is the minimum value of the expenditure, monthly expenditure. And then this is the maximum value. And step size, you don't have to consider it. And then current suggest value is 1,000. So this is a starting point, okay? So while you consider the multiple scenarios, and then you will start from here and then keep changing the value of the monthly expenditure until you have a minimum total expenditure. So after this, and then we can add actually constraint using this requirement. So don't use a constraint here because this is the goal of the, actually this is used for the other purpose. So you don't have to worry about this one. So let's use a requirement to add a constraint here. And click plus button so that we can add the expression here, and then type the root and adapters. So we cannot make sure that there is a certain policy having a certain number of adapters. Let's type the 80,000. Okay, right. And based on this, so you're done actually. This is a constraint for your optimization problem, and then this is this variable in your model, and then this will be the objective. So we want to minimize total expenditure, but we want to have at least 80,000 customers, right? Adapters. And let's create the default UI, and then you can have this optimization optimization menu, okay, in graphic, and save the model and run this fast diffusion optimization. And as you can see, I mean, if you run the simulation model and you already consider the about 500, and then so it has a feasible solution with the blue line. At the end, it will give you the best actually the scenario, and the parameters of this scenario, best scenario is what? So 2.388 will be the best value for your best scenario, and total expenditure was only 234, okay, dollar. And this means and then you can by spending only this money, you can have 80,000 adapters.